We've just spent the past many weeks learning, well, all kinds of things about polynomial functions. We've talked about solving them, graphing them, and of course making those connections. We're going to kind of shift gears a little bit and more generally discuss other math that you can do with a function. And so we're still talking about functions, but it's going to noticeably be a little bit different with the concepts. Now, one of those concepts is that we can just simply evaluate functions. Evaluating functions is really just a fancy word for plugging in x and finding y. But sometimes we actually don't have to plug in to find the y value, and yet, well, we will still have evaluated. So evaluating, finding the y value when you have an x value. Let's see if we can do that if we're given an equation. So if I have the equation b of x equals negative 4x minus 5, and I'm asked to find b of 2, we want to recognize that 2 is the x value. And when I see b of 2, that means that I want to plug in that x value. I want to plug it into the equation. And so basically, it's as easy as just determining negative 4, plug in 2, and then subtract 5. So this should be negative 8 minus 5, which of course comes out to be negative 13. Negative 13 is the value of the function. It is what you get when it is the y value that you get when you have an x value of 2. But it can look a little fancier. We can sometimes spice things up a little bit to find 3b of x plus 1. Now I'm highlighting that x plus 1 because that's still what I'm going to plug in. It's still what I'm going to plug in. But you have to recognize that this 3 that's out front is simply a coefficient. It's a coefficient that I will get in front of my plug-in. So what happens when you plug in x plus 1? Well, you're still plugging in for x, so it's still beside negative 4. But you don't want to lose track of the other components of this problem. So do you see I put x plus 1, I put that in for x, but I didn't lose track of my other components. I still have a minus 5, which is just tacked on to the end. And remember, I still have this 3, which is actually a coefficient in the front. So what's going to happen when you simplify this? Like, what does the simple answer look like? Well, it's going to require a little order of operations. So first of all, this negative 4 would distribute inside of these parentheses. Secondly, I keep my negative 5, and I continue to work out the order of operations, which I'm pretty sure says that negative 4 and negative 5 can be added or subtracted to get negative 9. Once I'm finally done inside the parentheses, then I can distribute this 3 that was out front from the beginning. And when you distribute that, you have negative 12x minus 27. Evaluating, finding the y value that goes with an x value. And we can also do that from a table. So if I see a table of x values and I see the resulting y values, well, it's actually pretty easy. As long as you understand that k of 2 is the x value, and all I need is the corresponding y value that goes with it. So k of 2 equals negative 10. K of 2 equals negative 10. That's it. There's nothing else that you need to do with that problem. What about evaluating from a graph? It's still the same idea. Understanding that that we have an x value and we have a y value. Oh, wait a minute, for this problem, I'm actually given the y value. Yeah, I'm given the y value of 1. Now, y equals 1 everywhere along this horizontal line. But specifically, that only happens at these 2 points, these 2 places where x equals -2 and where x equals 6. So for this particular problem, I'm actually being asked to find the x values. And so x equals -2 and 6. But if I'm given x equaling 2, if I'm asked to find f of 2, then I'm asked to find the y value. And the y value that goes with x equals 2, well, that y value is going to be everywhere along this vertical line, which only happens down at this point when y equals -3. So notice that for this second problem, I'm given the x value and I'm asked to find the y value, which happens at -3. Now in class, these next groups of problems in these boxes, I would assign to various tables to various students, and each would be responsible to try to work out the answer. So what are you going to do? Well, I encourage you to work these out, but I would like you to still have access to the answers. This is one of those times where you want to push pause. You definitely want to try these problems, work them out, and then you can come back and see if you got them right, as I will be giving a quick analysis of each of these problems. G of 3, or G of -3. Plug in -3 to the G equation. Square it very carefully. Square it. It's always positive. So you get 14. 7, f of -4/3. Well, 7, kids, is just a coefficient. It's just a coefficient that's on the f equation. So it's going to be in front. It's going to be in front of my 3. Now my -4/3. And then don't forget the +2. So it's kind of like I put a 7 in front of this equation. But again, I also plugged in -4/3, which is the main part of the evaluating. 7 times -4/3. These 3's are going to cancel and just leave you with -4. As I keep doing the order of operations on the inside of the parentheses, I eventually get -14. H of 4. Just plug in 4, but make sure you plug it into the H equation and make sure you plug it in both places. So I plug in 4. Do the order of operations, which means definitely do the exponent first, then do the multiply. Finally, you do the subtraction. H of A. H of A. H of A is actually asking you to plug in A. Now you're going to plug it in to the H equation, and the only place that you plug it in is in the spot where X was. So it looks like that it's going to end up being plugged in or sort of sat in both of these positions. Well, nothing really happens. I just get 3a squared minus a. But if you plug in something like 2x minus 3, now something's going to happen, because I'm going to put a 2x minus 3 into the x position. Now, when I put that in, I need to be sensitive to the fact that it's going to get squared, but I also need to be sensitive to the fact that there's a subtraction sign, and this subtraction sign is actually in front of the entire quantity. Parentheses. I need these parentheses to make sure that subtraction sign is applied correctly. Now, order of operations. You have to do the 2x minus 3 squared. That is 2x minus 3 times 2x minus 3. I have to do that first. When I do that very carefully, I get 4x squared minus 6x minus another 6x, which is going to end up being minus 12x. Finally, you get a plus 9, and I still have this subtraction sign out here. Remember, you're subtracting all of this. Now, the number 3 that's in front, that number 3 is going to distribute. It's going to distribute, and everything gets multiplied by 3. Very carefully, I'll get these new values. My subtraction sign, I might as well distribute that so that I actually get a negative 2x, but a plus 3. Combine some like terms, and this is the type of answer that you're going to get. The answer comes out to be, well, it comes out to be an expression. It's still the value. You're still evaluating, but it's just that the answer is an expression. 10f 5x. 10 in front of the f equation. The f equation is denoted by a 3 times whatever I'm going to plug in, and then again the plus 2. So I have a 10 in front, but working on the inside, I get a 15x plus 2. Multiplying or distributing the 10, eventually I get 150x plus 20. Now, the problems on the back, everybody's going to do on their own for a little grade. You have a good sampling of problems. There's some equations, there's some graphs. So you're going to very carefully work through these 12 boxes, see if you can evaluate each of these correctly.